Hi algebra students, find your 3-7 cost, income, and value chart word problems notes template. I want you to try the warm-up that is a chart. You're only doing the chart setup and equation only for the problem. The length of a rectangle is 8 centimeters more than the width. A second rectangle is 5 centimeters wider and 6 centimeters longer than the first rectangle. The second rectangle has a perimeter of 242 centimeters. Find the dimensions of each rectangle. So go ahead and fill in your chart and write an equation. So I filled in the information I know. I know that I am talking about rectangles, so I need a length and a width and a perimeter. I'm only told the total perimeter of the second rectangle, so that is the rectangle that I'm going to base my equation upon. I have x plus 8 as my length of my first rectangle, x for the width, whereas the second one is 5 centimeters wider, so it gets x plus 5 and 6 centimeters longer than the first rectangle. Just make sure that you're always basing your rectangle and triangle and circle problems on the basic formulas that you should know. And I'm basing my equation on the perimeter formula of a rectangle, which is twice the length plus twice the width, and that's how I'm setting up my equation. The next section of your notes is kind of a word bank of formulas that you're going to write down. There are 3 different types of situations we're going to base equations upon. The first one is total cost of items, so we're going to fill in that equation. Second one is total income, and third one is total value. So to find the total cost of items, you're going to take the number of items that you have times the price per item. To find the total income, we're going to take the number of hours worked times the wage per hour. To find the total value, we're going to take the number of items times the value per item, and you'll notice that the first and the third equations are kind of the same setup here. Just a review of some money, we can look at coins in different ways. We can look at them in dollars and in cents. I filled in nickel here. So nickel is 0.05 of a dollar. The dollar sign goes to the left. But if I list it in cents, we're going to list it with the whole integer 5 with the cent symbol afterwards. So see if you can fill in for dime, quarter, penny, and half dollar. So go ahead and check your charts with mine. Dime is 0.10 of a dollar, but 10 cents. Quarter is 0.25 of a dollar, but 25 cents. Penny is 0.01 of a dollar, and 1 cent, and the half dollar is 50 cents, which is 0.50 of a dollar. In example 1, I'm asking you to examine the value of 6 nickels by showing some work. And you can look at this just like you did in the chart on the prior page. You can look on this in dollars or in cents. So go ahead and write the expression that would show you the value of 6 nickels in dollars and then cents. So here I've got my total value for 6 nickels in both dollars and cents. And I want you to try the your turn where we're looking at the value of 3/4 and 4 dimes. So you'll see I've listed it both in dollars and in cents here. Total for dollars is $1.15, and total for cents is 115 cents. And in most cases, the word problem will determine which one you want to set it up as, whether you want to set up values in cents or in dollars. Looking at example 2, if I know that I have a total of 10 coins that are only dimes and quarters, and I know that 4 of them are quarters, how many dimes do I have? I'm going to set up the simple elementary addition problem where I've got 4 plus a mystery number, which represents our number of dimes equals 10 total coins. So that means that there must be 6 dimes in my pile of 10 coins. Then I'm going to find the total value of my coins by following those equation recipe cards from the first page of notes. So setting up my total value of my coins, I'm going to just choose to look at the coins in number of dollars or in values of dollars. So that gives me 0.25 of a dollar times 4 plus 0.10 of a dollar times 6, which gives me a grand total of $1.60. Try the your turn. If you have a collection of 60 quarters and pennies, how many of each do I have? So if I make X my number of quarters, that means to find my number of pennies, I've got to take the total number of coins, which is 60, minus what I already have, which was the number of quarters. So if you set X equal to the number of quarters, your number of pennies is going to be represented by 60 minus X, but those could also be switched. You could also have X being the number of pennies, which would make the number of quarters 60 minus X. To find my total value of my coins, I'm going to set up the expression 0.25 times the number of quarters, which is X, plus 0.01 of a dollar times 60 minus X. And in this case, these parentheses are necessary because the value needs to go to both pieces. For the next word problem, I'm going to look at an apple selling for 25 cents and a peach selling for 15 cents. A total of 10 pieces of fruit were sold for a total of $2.10. How many apples were sold? So I'm going to base my chart setup on the word problem from the first page of our notes, where we looked at the total cost is the number of items times the price per item. So I'm going to fill in the prices that I was given in the original word problem. So I filled in my price per items in dollars, but again, you could do integer answers of price per items in cents. I'm going to fill in the number of items by choosing one of them to be X, and since I know the question is asking me to solve for apples, I'm going to go ahead and make apples my X, because then once I get my answer, I am done. And then to find the number of peaches, I'm going to take the total number of fruit, which was 10, minus what I already have, which is the number of apples, or X. Now you'll notice that when I set up my chart, I made my multiplication in between the first two columns and my equal sign before the third. That's going to help me when I go to fill in the total cost, because I know that I have a total of 0.25 times X to find the total cost of apples, and 0.15 times, in parentheses, 10 minus X to find the total cost for peaches. But I'm also told in my problem that I have a total of $2.10 total. So when I go to write my equation, I'm going to take the total cost of apples, 0.25 times X, and add it to the total cost for peaches, 0.15 times 10 minus X, and I'm going to set that equal to $2.10. And then I'm going to solve. So following through on my equation solving here, I distributed my 0.15 to my 10 and my minus X, combined my like terms, subtracted 1.5 from both sides, and divided by the coefficient in front of X, which was 0.10. And I'm finding that X is 6, which means in terms of the problem that 6 apples were sold. And you're going to write that in a sentence answer. Let's take a look at the same problem, but instead of putting our values in dollars, we're going to put them in cents. So I've erased what's going to be affected by the problem. I'm still going to leave X as the number of apples and 10 minus X being the number of peaches. The most important part of setting it up so that values are in cents is remembering to convert the original total value of all of the pieces of fruit. They give it to us in dollars, and when I convert my price per item to 25 and 15 cents, I need to also change what I'm setting the right side equal to in my equation to be 210. And then we're going to go ahead and solve. So either way that you set up this chart and word problem, either in dollars or in cents, you should be getting 6 apples, and you'll see my work here is included for solving for cents. So here's my chart set up for the your turn, and you're going to go ahead and pause the video, and I want you to fill in as much information as possible. You can choose to leave the values in dollars, or you can give them to me in cents. So if you set up your chart by writing the value of nickels and pennies as whole number integers in cents, your equation is going to look like mine. The trickier part here was having 4 fewer pennies than 3 times the number of nickels. You're comparing back to nickels, therefore that must be X under the number of coin in your chart. and the number of pennies should be represented by 3x minus 4. Multiplying across the top, you're going to have 5x, and 1 times 3x minus 4. I didn't bother writing the 1 because distributing a 1 is just going to give you the same expression, 3x minus 4. I'm going to total them up, and because I chose to write in values of cents, I need to change the total value of $1.80 into 180 cents. Go ahead and solve for x. So solving that equation, I'm going to find that x is 23, and I need to write a sentence answer something like, he has 23 nickels, and then I need to plug in to find the number of pennies. So I'm finding that Carl has 23 nickels, which we found with our x value, and then I plugged in 23 to the number of coin for pennies column, and that is 3 times 23 minus 4, and then that gives me a total of 65. In the next section of notes, I just want you to look at buying items versus selling items and what it does. It's a little cut off in the top. It should read, when you buy something, does this make your money increase or decrease? It makes it decrease because you're spending your money. And when we do things that are bought in our equations, we're going to represent them with negative numbers. Next, we take a look at when we sell something, does it make your money increase or decrease? It makes it increase because you're earning money from that sale. This is called profit. And when we represent something that we have sold in one of these word problems, it will be a positive value. The general rule of thumb is when we're looking at a profit problem, we're taking the amount we sold, which is a positive value, and adding it to the amount we bought, which is a negative value. We're going to look at example 4, which is David paid $1.50 each for programs to the basketball game. He sold all but 20 of them for $3 each, and he made a profit of $15. How many programs did he buy? So we know he bought a total of 20. We want to know how many he bought, so let's make X the number of programs that he bought. And that means that to set up sold, we're going to take 20, the total he sold. Okay, scratch that. We are going to take the total he bought minus 20 because we're told that he sold all but 20 of them. The price, I'm going to leave in dollars. He paid $1.50 when he bought them, and he turned around and sold them for $3 each. Multiplying across, that means the total cost for bought was $1.50 times X, and the total cost for sold was 3 times X minus 20. But we know that when we're buying something, it is subtracting our money, so we're going to make this a negative. Looking at our equation, we're going to add up what we have. The total cost for bought was negative 1.50 times X. We're going to add that to the total cost for amount sold, 3 times the X minus 20. Our profit is the difference of money. It should be more money if you're doing well, because that means that you spent less than you earned, and therefore it's called a profit. His profit was $15, and we're going to solve for X. When I solve the equation for X, I'm finding that David had bought 50 programs for the basketball game. It's not asking us for the number he sold, but if it did ask for that, we could find that by plugging the 50 into the equation 50 minus 20 to find that he actually only sold 30 of the programs. Looking at the last problem, we're taking a look at Celia buying 12 apples. She ate 2 of them and she sold the rest at 20 cents more per apple than she paid. Her total profit was $1. How much did she sell each apple for? Go ahead and pause the video and see if you can fill in the chart. So looking at our word problem, we know that she bought 12 apples. That's my number of each bought. She ate 2 of them, so selling the rest means that she was only able to sell 10 apples. I'm going to put my values in cents. I don't know what she bought them for, so I'm calling that price X, but we know that when she turned around and sold each apple, they were 20 cents more per apple than when she bought them. So that price is going to be written as X plus 20, making our total cost for bought negative 12X, because remember it should be negative since that's the money she's investing, and our total cost for sold being 10 times in parentheses X plus 20. We're going to add them up and set them equal to $1, but in cents that should be 100 cents. Solve for X. So Celia was able to sell each apple for 50 cents each, and the question, well, she bought them for 50 cents each. The question is asking how much she sold each apple for, so we need to plug the 50 in for X to X plus 20. So that means that Celia was selling each apple for 70 cents. Make sure to bring any questions in for your math teacher on the next instructional day.